Hi everyone, in this video we are going to talk about traits. I really love this topic because even though it looks really complicated, believe me, it is not. So, what are traits? So let's give an example. I'm a human, I have a cat, and there are birds outside. What's in common is that we make noise. So, three different types making the same action. For that reason, we separated the action from the doer so that we can implement this action for every animal that is making sound or any other type that is not an animal maybe but making sound. So we create a trait that is make sound trait. Then I create three structs: person struct, cat struct, and then bird struct. And I implement a couple of methods for these structs, and one of the methods is this make noise method. And even though I'm implementing the same method, I'm defining the body, I'm creating the method in different ways. So even though we all make sound, the sound that we are creating is different, but the idea and the functionality is the same. And this is the connection between different types, and we can have this connection through traits. So enough of the philosophical talk. Let's see how we can define traits and how we can use them. First, I'm going to define my first trait here. We say trait, and I will say speak. And in this trait, I can define functions that I want to implement this with. And my function is speak here, and this is going to take self as the parameter, and that's it. I didn't create the body of this function because whichever type is implementing this, they are going to define it in their own way. Now let's create a struct. And let's call it dog. And here we will have name, let's say string. Then we are going to say implement speak for dog. If you remember, when we were implementing for structs, what we were saying is implement dog. So that's how we defined the methods of the struct. But here what we are doing is we are actually implementing the speak trait for this dog struct. So we are indicating that we are actually implementing this speak for dog. And inside this, we are going to say function speak. We need to say this because it has to be the same function signature. Here we will say self. And after this point, we can customize the method. And I'm going to say println, let's say, says woof. And we will say self.name. Alright. So what we did is we have a trait here and we have a struct here, and we implemented this trait for this struct. And now let's see how we can use this. Let's first create the instance of this dog struct. I'm going to say let dog equals dog. I know I'm not very creative here. The name, let's say Rudolph. That to string. Next, we are going to call the speak function from the dog struct. And for that, I'm going to say dog.speak, and we are going to run this. First, let's build our code. Everything looks fine. And now we are going to run. And we can say Rudolph says wolf. But we can also implement this for other structs too. Here, let's create another struct. Let's say cow. Everyone thought that I was gonna say cat, right? And I will say name. And then we are going to say implement speak for cow. And we will say function speak, and the parameter will be self. And as we talked, the signature must be the same, but the body of the function can vary. And here we are going to say not wolf, but meh. Alright, now let's create another struct instance here. For this, I'm going to say cow, not that creative though. We will say name, not Rudolph, but to string. So we have Rudolph, which is a dog, and we have not Rudolph, which is not a dog, a cow. Next, we are going to say cow.speak. And let's run this again. Now Rudolph says woof, Patika.dev says meh. So the difference is that we had the same trait, but we implemented differently, and even though they both speak, they create different sounds. So this is the main ideology behind traits. We are connecting the behavior of different structures through these traits. We don't have to use the traits to have the functionality for these cases, but this just tidies up the code, creates the connections, and just a better constructed way to write your code. And this is just a smaller code that we are writing. These are just basic examples. Imagine you are writing a really big programs and projects. For that, we need traits, and we are also going to see a couple other reasons to use traits which are very unique. But even this connection between the different data types should be enough to convince you to use traits. Here we implemented traits for the structs that we created, but we can actually implement traits for the data types that we are already using. For example, here I'm going to create a new trait, and I'm going to call it display. For the signature, I will say function display self here, and then we are going to return a string and semicolon at the end. And then I'm going to say implement display for string. So string is a data type that we are already using, but I'm going to implement this trait that we created for the string. And for this, we are going to say display self. We cannot change the signature of the function. So this part is pretty straightforward every time. And here we are going to say self.clone. So what we are doing here is that we are just getting the clone of a string. And if I want to use this function, I would say let's say original here, original string equals string from, this is original. And then we are going to create the copy string, and for that we are going to say original string dot display. As you can see, what we are having here is a return value which is a string, which is the same value we are just cloning. So what we are expecting to have the same value of this variable here. So even though we set copy string here, the value we are expecting to hold with this string is the original string. So saying this is original. So let's print out and see if this works. And I will say copy string here. And as you can see, this is original. So this is another way to use traits. We can use this for the structures that we create, but we can also use this for the already implemented structures and enums. Now let's see how we can use traits with functions. Here we have two different structs, the dog and the calf struct, and we have implemented the speak trait for both structures. And here we are going to create a function. For this function, we are going to say function, let's say animal speaks, and here I will say t, and the kind will be speak. And then it will have a parameter, and this is the animal, and this is the t reference. And here I will say animal dot. So let's see what's happening here. So we created a function. So far that's okay. We just said fn and animal speak. But after that, what happens? So if you remember, what we said is with the enums on the option and the result enum, we were having these values t. So with the option enum, what we were having is this t here, then we had some t, and also we had none here. So we said that this is just a placeholder. Whatever we put here is going to be here. And we did a couple of examples on this. So this is a similar ideology. We are saying, I'm going to provide something to you, I don't know what I'm going to provide to you, what type, but I know it implements speak trait. So I know it speaks, but I don't know what it is. And here we are using this generic T again because this can be any type that implements speak. The difference from the option is that we can put any type for the T and we would have in the sum. But here we are saying I will have T, but I will have T that speaks. So we are actually filtering the endless possibilities that we can put here. So through this, we can use these traits as objects so that we can use them in our code, in our functions. And let's try to use this. Here I'm going to say animal speaks, and I'm going to provide the reference of the cow. And then I'm going to comment this out so we can see. Also this too. As we can see, it says not Rudolph says more. So we were able to call this function, and if we say this, and if we say dog, fingers crossed, and yes, Rudolph says woof. So as you can see, we implemented a method here, and for this method, we said that we are going to accept parameters, but these parameters must be able to speak. So this is the way that we can use traits with our functions. And if we provide any other data here, if we say that my string equals string from Simon, and then if I say animal speaks, and I give the reference of my string here, if we say cargo build, we can see that we had an error. It says required by this bond in animal speaks. So we are bonding our data type to have this functionality to implement this trait here. So let's delete this example. Now let's talk a little about inheritance. So with inheritance, what we can have is we can have a parent trait and a child trait, and the child trait would have the functions of the parent trait and some additional functions too. So let's see how this works, which is easier to understand through example. Here I'm going to create a new example so it's a little bit easier to understand, which will make a little bit more sense. Here we set animal, and inside this trait I'm going to say make sound this time. I'm going to create a function called make sound, and it's going to take self. So this is my animal trait. There's nothing new here. This is very similar to our speak trait. But here I'm going to have another trait, and this trait is mammal. And here I'm saying this trait is animal. So by saying this trait is animal, I am inheriting this function here, and then I'm also adding one more function. I'm going to call it walk, and we are going to say self here. Since many animals make sound, but not all animals walk, we are inheriting the functionality here. We are saying we have mammals which can walk, and they are also animals, so they make sound. We can have another type of animal here, and we can add the functionality as saying, let's say, trait, bird, and it's animal, and let's say, fly. As you can see, I have my animal which makes sound, and I have my mammal which also makes sound because it's an animal and which also walks. And I have the bird here which is an animal, so I got my make sound function, but I also have my fly function since this is an extension to my animal. And now let's see how we can use this. First, let's create a struct, and I'm going to call this struct cat. And then I'm going to say implement animal for cat. Here we are going to say function make sound, and we will have self as the parameter. And inside this I'm going to say println, and let's say meow. And then I'm also going to implement mammal for cat, since it can make sound and it can also walk. We will say function walk, and here we will say self, and let's say println, and here let's say the cat is walk. You know how they walk. It's a little bit funny. Alright, now we implemented our animal and mammal traits for the cat, and let's see how it works. Here I'm going to say that cat equals cat, and then I will say cat dot make sound, and then I will say cat dot walk. Let's run and see if it works. Now we can see cargo run, and now it says meow and cat is walking. So as we talked in the beginning, it's a little bit complex and big topic, but it's fairly simple after we understand how we can use it. And finally, let's talk about default method implementation here. For that, we are going to, let's go to our animal example, and here I'm going to create another function, and I'm going to say sleep, and here I will say self, and then I will actually create the function, and for that I will say here animal sleep. So before that we were creating the signature, and whichever structure wants to alter this signature, they were implementing their own way. But here we can also create functions which we call default methods. So without creating our own version, we can directly use this. Since our cat implements animal, now we are expecting it to work with our sleep. So let's see. I'm going to say cat dot sleep. I'm going to say cargo run, and voila, we have animal sleep. So this is the general introduction to traits. We are going to use traits much more in this course, so we can get used to it. For now, thank you very much, and I will see you on the next one.